All right. So my presentation is on Introduction to Python. And my name is Charitarth Chugh, right? And this for UCSA is 2022. So I'm a second year computer science major at UConn. I also am math stat now. And I'm also secretary of AI Club. My current interests are deep learning, Linux, and software development. So why would you use Python? Okay. Python is a language for very diverse applications from software development to research, right? So theoretically, you can actually look in, actually you can actually analyze all your data, then do stuff on top of your data, then build an application on top of that, right? Within Python, you don't have to go to another language or another tool, right? Because libraries are there. The whole thing about Python, and it's why it's becoming like harder to replace. It's not is basically the ecosystem of libraries that it has, and that's like the main advantage. It's like hard if you want to go from, let's say, a data science stack, right? It's hard to go create that in a whole new language, so that's actually a whole lot of cost. And that's why there's only two languages. One was one you saw earlier, R, in this room, and the other one's Python. And as a language, it's very easy to understand because there's been an emphasis put on readability. And that's like with more English-like syntax, it's obviously it retains some like programming aspects, but it's more natural language per se. Yeah. And also, it's also really easy to create your own Python package that you can have other people import, and now that has functionality that didn't exist before, or better than before. So prerequisites for this workshop is basically a device with internet access, preferably a laptop, because we're going to be using a co-op for practice. Yeah. Sorry, we actually won't probably have time to do NumPy and Pandas, so I'll have to remove that later. But okay. So basically, what we'll be covering is Python syntax, data types in Python, that includes strings, numerical types, mappings, sets, and data types, sets, and conditions, loops, and functions. So basic Python syntax. So to comment something, you just prefix with a what is it, hash, and to actually a new line indicates a new command. You can use semicolons like other programming languages, but it's usually not used unless for like very niche instances. And let's start with data types. So you have integers, floats, complex, which I actually did not know before actually doing this presentation, which is very interesting. So like complex is for obviously complex numbers. So 1 plus 3j, where 3j is the complex component of the complex component and complex notation. And booleans. And the thing about Python booleans, like often actually tripped me up when I was learning, is the capital T instead of the lowercase t. Right? Because if you're used to other programming languages, and especially with like C style programming languages, right? They're always a lowercase. But here in Python, it's actually an uppercase T. And here's some more data types. And like what data type we'll obviously be working with a lot is strings. And Python actually has really good string manipulation built in. So a string is basically a list of characters in Unicode, and which actually in Python you can index, which I'll talk about in a bit. And multi-line strings are basically strings that preserve formatting. So if you want to have strings print out in a certain way, preserve their spacing, you can actually do multi-line strings, and all the formatting and within that string is preserved. And it's key line breaks, which is basically the formatting. operators like plus, concatenate strings, and in searches for membership. So if you're trying to see if a set of characters like appears within a string, you can use in to actually find that. And some commonly used methods are replace, split, and upper lower strip. Strip basically what it does is sometimes you're not able, sometimes you get input with, let's say, an extra space, and that often, in some problems actually, like some instances, that's actually very annoying. So you can just use strip to remove like the spaces at the very end. Like at the front, it'll remove the spaces, and at the end of the a string. Capitalize is just capitalizing a string, and caseful is just changing the case. Yeah. And count is like counting number of instances of certain character appears and ends with, starts with. Those are pretty self-explanatory. So if it ends with a certain string, find also does something like in, but it'll be probably more like probably a bit better actually because an index you can find the index of a character probably. Right? There's actually a couple of types of strings in Python. So F strings are actually really useful. You'll be using them a lot. So basically what you can do is have expressions within the string that will be evaluated at runtime. So when you actually go run your Python script or program, it'll actually evaluate the expression and convert it into a string. Then it'll actually print that out, especially when you like print it or like store it where like as you wish. So it's really useful in debugging when you're trying to see, hey, what's the value of this variable? And I'll talk to you about variables in a bit. R strings are actually useful as well when you want to make sure that string, like the content in the string, cannot be modified, and they can be modified, but they like you are more sure that they're not as easily modified, and they're like exactly how it is. And it's really useful when you're actually working with files. So you're trying to specify the location of a file. You want to make sure it's exactly this path to the file. Okay, here's a practice, right? So please go to that. It's just basic string manipulation. And you'll have about 4 minutes to do it. Yeah. And I'll spend like 3 minutes doing it after. Actually, and I'll be honest, I haven't actually done solutions. I'll be coding it for you. Everyone has access to Colab file? On Google Colab? All right. Has anyone joined? Let me pull up myself. All right. And film that. Okay. And if anybody wants to volunteer and come up in here and do it, please feel free to do it. Right? Everyone done? No? Alright, I'll give you the next minute.
I don't know.
Alright. So, to slightly throw you guys off, what I would do, what I actually put it in a way that, so you would actually, you wouldn't have to actually split it first. I would actually replace it first, and you can split it. It doesn't matter the operation, like which order you do it, but if I haven't taught you loops yet, we'll get to it in a bit, but that will require you to know how to use a for loop and to like go through each element in the list that you'll get. So we can do dot, let's just run this, run anyway. One sec. Right, dot replace B I. Then you can just chain the method because the result of replace would be still a string. So you can do any string operation on top of that. So you can do split. And that should, yeah, there's your result.
Is the period like, is that like you take the result and then of that and then kind of like the
The period is just like indicating a function. So basically, here's your input, right?
Okay.
That's basically a string. You can apply a function on top of the string. Because we'll get to class and objects. Because everything in Python is object, right? So you apply something to the object.
Okay.
That's what.
So you don't put like split and then put that thing in parentheses.
Yeah.
Is what I was trying to do.
Like put.
So like, I've done with, I'm familiar with R, so my first thought was, I need to name that something.
Okay.
And then like call it string,
Yeah.
and then I put
Okay.
split, and then in parentheses I put
you
string.
would set it. You would set it to a variable.
Right, yeah.
Yeah, I'm not into variables. I personally would have done that as well, just like the feasibility. But it actually doesn't.
Okay, so but this is, it allows you to kind of dot, so you put the thing and then.
You just apply the method on top of it.
Why couldn't you do the split for the replace again?
The split would actually just make your life slightly harder. You can do it,
So why
because I haven't taught you loops yet, basically. You basically would get a list.
So it's not vectorized like R is?
Yeah, you can make it into a vector like with a matrix. It's because in list you can basically store anything. And then there's libraries that actually are for vectors. That won't cover, but yeah. All right, and here's lists, as I was talking about. So they can contain any types of elements and even a function inside them, and you can mix and match. And they honestly actually don't care. A lot of the things in Python don't care about the input type, and Python only reports an error when you try and do something that's not supported by the input type. It doesn't actually check that, hey, this is the type, this is this type, and you're trying to apply different methods type on top of it. It'll only check if the function or whatever you're trying to apply is valid. It won't actually check the input that you'll get. If you get what I'm trying to say. So they're indexed and ordered as a sequence. So you can actually, for each element, you can easily get the index and loop over them. And indexes start at 0, like most programming languages. And Python's indexing is actually very good, in my opinion, because it's basically because of its slicing. So what slicing does is return a new list of, let's say, :2 basically returns the last two elements. You can specify the range of the indexes where the condition is mapped, basically the range. I didn't explain that well, my bad. And 2 colons basically after 0, 1, 2. So basically, including true, it would go. But for colon 2 would be not including the last. So elements can be modified at the following things. You can just say, here's this here's this place, and here's the elements that you want to put at this place for those two values. And some methods supported by lists are length, and length is actually and length is Python is slightly different, so it's actually a regular method. And what happens is it'll call a special method within Python. It's literally called len, and it'll do that to get the length of any object that you create that has a length. Let's say, what is it? A list, for example, is one. Then a vector as another. If you want to create your own vectors, and x.insert is basically at the index 2, so that's like third from the start. So insert the string Python, and append is basically adding it to the end of the list, and remove everything else is pretty much just self-explanatory. Remove, it'll remove I think the instance of the array 1 and 2, and pop removes the last element. Pop is basically removes the element at that index. And x.sort basically is list.sort is basically sorts the list. And the thing about Python is what it'll do is if you set a variable equal to another variable, like a list, right? It won't copy it. It'll point to the same exact thing. So you have to actually make an explicit copy if you want to work on a different thing that originally contained the same elements, and you don't want to modify the original. And x.extend will extend by basically concatenating the list. Oh my god. Tuples are very similar to lists, and they're created with parentheses, but elements inside them cannot be changed or added. It's called immutability, and they are basically constant. And you can't do anything to them, except for if you want to change, you basically have to go create a whole new tuple or object in the list. And accessing is similar to the list, so you can index them really easily and get counts and stuff like that. Sets are actually a really nice feature of Python, in my opinion, because they're known to be actually very fast. If you actually go study the runtime, they're really one of the fastest indexable, not indexable, fastest way to store things. But the thing is, you can't include duplicate elements, so it's also nice if you have a lot of duplicate elements and you want to actually remove them, you can just put them into a set and it'll take care of it because you can't add duplicates, so it'll just ignore that, basically. It's not able to be indexed though, so the only way to actually access the element is actually to loop over it. A dict is a dictionary. Most people call it a dict. Is basically a key value pair map data type. So where basically a key is used to access value. The keys of the dictionary are immutable and cannot be changed. Actually, they can be changed. And duplicate keys will actually replace the original value. So if you try to insert something with the same, assign a variable and given a key, right? So basically, you have UCSAS year is equal to, let's say, next year, so it's 123, it'll just overwrite 122 that's already there.
And that is case sensitive, so if I did year with a capital Y, this would be different.
Yeah, it'll be a different thing.
Okay.
You're still using a string, so the string itself would be different. Okay. If you want me to slow down, please let me know. All right. So data types. Obviously, this is not an exhaustive list. There's so many, and you can actually go create your own. So if you ever actually need to inspect the type of anything, there's a nice built-in function called type, and it'll show you the type of the object that you're trying to use. And variable assignment is actually very simple, and like most other programming languages, where you just set a variable, let's say 2 equal to x equals 2, basically that sets the variable x. You create the variable x, and it'll be equal to 2. And then the print statement will print it out. So that's actually pretty straightforward. And here's another practice. It's the same link as before. Yeah. Okay. Actually, don't. Okay. Yeah. This one actually I can close this one. Let's shut it a bit later. So yeah. Don't actually worry about getting the solution because there's some parts I've touched. That's it completely my bad. So. Don't worry about it. It's completely my fault. So, yeah. Basically, what I'm trying to do here, unless you want to actually figure this out. The more explicit way of doing this is Is everyone ready? All right. So I haven't touched for loops. This is completely my bad. That's why I'm like, oh no. So basically, for loops are basically I'm trying to iterate over the list of numbers, and every time I was like the value I get, and I try to when I get for it basically goes first in I is the value you get at that first index, so loop over each value. And then I use I as a variable to get an index, basically. So, yeah, okay. So, I is basically being used to fetch an index, and that's used to set the value there. You want me to explain it better, or do you guys got it? It seems like you guys.
So I and nums there, are you looping over 0, 2, 1, 5, 3, 4, or are you looping over like the index?
So basically, in the inner nums, you use that to get the index that you want to set it at, or variable at. Like the index to get the value.
So nums is being used here as a list, like an index.
Yeah. Indices, then you use it again to get like another value within nums. So basically, what will happen is like at the second index, right? So first get at 0 index, what's the value? Like what's at 0 is the value, right? And the inner part of the num, so I'm trying to index it. Then we'll do, hey, now at the index, I'm going to get the index again, right, and assign the answer. So here are some operators in Python. So here are the basic ones. So like add, subtract, multiply, division, modulus, exponentiation is actually like that, or it's like built in with double star, and floor division. Assignment operators are also like fairly simple. So equals is if you can I showed you that a bit earlier. And equals basically on the other side, like here's the variable on the left hand side, right? You can and here's the value. You would first add that value to the variable, then assign it. And this is actually more if you've heard of C and C style languages, that's actually where it's coming from. All right. Then subtract is equals, but subtract and equals basically doing the same thing. Multiply, divide, and stuff like that. And it's supported for any operator, like arithmetic operator that is shown above. Then comparison operators are actually very simple as well, in my opinion. And so value equality is like double equals. So basically, and what's going on under the hood is basically it's called on the first object you're trying to compare to, it's calling an equality method that's within it that checks, hey, let's see, this variable, this item in there is the same, this other thing in there is the same against the thing that you're trying to compare against. Right? If it's not equal, it'll do the reverse of that, and greater than, less than, value greater than equal, value less than equal. If you get thing that I like about Python is like you can actually make these yourself, right? You can define like, hey, here's how I want to compare if it's less than or greater than equals to. You can actually go ahead and define that yourself for the things that you want to create. Logical operators are and or not and in. In I mentioned a bit earlier is basically trying to see if like something is inside a list or a tuple or anything that can be indexed. And it's basically here's this one condition, here's the other conditions. Let's check if both are true or both are false. And if both are true, but it'll return true. If both are, one is false, it'll return false, and anything greater than one being false, it's still return false. Or is basically, hey, one side is true, the other side is false, it'll still return true because one value is true. And not is basically negating, let's say, this object is not inside something. You try and negate that. Now we're going to conditionals. Conditionals should be based on logical input, logical operators, such as double equals, greater than equals, and stuff like that. And they can be written in one line if the statement has only one statement. So basically, there's only one thing you want to do when you already know it's true. Here's the only thing that you want to do. An if statement cannot be if Python, due to its syntax, an if statement cannot be empty. You can't just have an if statement without anything to do. Right? You can still not do anything there using the keyword pass. So let's just if this is true, let's just pass over and let's start doing other things. Let's start checking over other things. If a condition are to result in two more braces, right? So you can use else if to actually check. The first one is not true. The first if is not true. Now, hey, let's use else if. See if this is true or not. So that's another conditional that you can use this, and you can chain that, and do that. At the end, okay, just to verify, yeah. So basically, first line is setting A, B, and C their respective values, and second line is now you're going on to if statement. So if A is greater than B and A is greater than C, those print out, but obviously is not greater than both of them. So go to the else if. If A is less than B and B is less than C, it'll print out C is first, right? Which is what it actually goes to print out. Otherwise, it'll say B is the largest, because then you basically have that B is greater than A or C. And so, okay, so basically you try and see in the second bit is you just do that all in one line, because Python lets you do that. That's so now we get on to loops. A while loop is as you saw earlier, my assignment a little bit earlier in R is basically it runs as long as the condition is true, and you have to be a bit careful to not run into infinite loop. And you'll be like, why is my program still running? Right? What am I doing wrong here? And it's probably because of an infinite loop condition that you have. You probably have to fix your condition for the while loop. And break and continue allows you to break or continue based on condition. So basically, if you reach condition within the while loop and you want to stop, but that's not the original condition that's being satisfied, right? And the original condition is still being satisfied, you can just do the keyword break and it'll break the loop right there. Otherwise, you can just do continue and skip over that. So here's basically, I have, in the code example here, I basically have a really long number, right? And I'm trying to count how many digits are in there. And I'm just double checking if the number is less than 0. If it is, then I'll just break. But this is after obviously not equaling 0. Then I use the modular operator and modular assignment operator. So see if I can still do the modulus, and that will not equal 0. And then every time I can do that, what happens here is I can just increment the count to see how many digits are in there. the resulting value would check this count. And a for loop is in Python, you're actually iterating over a list or iterator object. So most of the time in Python, you're actually in a for loop, you're supplying a list to iterate over, right? You're not iterating over indexes per se. To do that, to iterate over indexes, right? You can just use the range to get a list of numbers, say so let's say 1, 2, 3, 4, 5. Then you can use that as indexes to do that. So here in the first part of the code example, what we're doing is trying to find the count of usual. So if the current index, the value of that current index is usual, it'll just increment the count, and I'll print out the count afterwards. Then we reset the count, and yeah, and here's another way to basically do that for each variable in X, right? You can do a call like an if statement to check if it's equal, and count plus equals 1. So you don't actually need to use indexes all the time to access the variable. It will while you're looping. And here are functions. A function is actually defined using the keyword def and followed by the function name and argument supplied with the parentheses. And a function should either print or return some value. Actually, if you don't define anything to return, it'll still return something that's called none. So it's nothing to give you back. Right? Also, you should but in any case, if the function should actually contain something. Otherwise, you should use pass like in if statements to not do anything. This is because the Python syntax are basically using indentation and colons instead of let's say parentheses, brackets, which are not space dependent, so they require the use of spaces for syntactical reasons. Often when we use functions to obtain values and store them, and so basically we use a return statement to actually return a value to a function, then we can do more calculations on top of that on the resulting value. And lambda is a small anonymous function that basically here you can do this fine little function in line that just multiplies against constant value, for example. I don't actually probably not able to put the syntax in there, so that's my bad. And we can talk about scope. So basically what that means is here you're defining a variable inside a function, but you can't actually, it's local scope because you can't access it outside of the function. You would actually have to declare it by using declare it as a global using the global keyword, which most people don't do because it's not required. You would just create it outside of the function and access it that way. And it can actually be accessed by other functions if the function is inside a function, which is actually a cool feature of Python. You can write a mini function that stays inside the function. And we're doing Catalan numbers, same like as before. And okay, this is getting weird. Yeah. Yeah, I know why the object is not rendering in Colab. So basically, I'll just write it in Colab. Oh. Yeah, my bad. There's some weird Colab error. So here's out. We're trying to search and then Fibonacci, so I'll put that one up as well to get a resulting value. Because the recursion is basically calling the function itself inside of it until you reach a base case where if you don't use a base case, which is the if condition here, right? You actually go into something like the infinite loop, and Python will actually complain about it at maximum memory reach, and that's how you know that you're actually in an infinite loop. So it's recursion is sort of like looping, but also sort of isn't. Yeah. Feel free to search anything up if you need help or just ask. Do anybody need some help, or
I thought I did it, but mine's giving me an error message, so.
what's the error message?
Invalid syntax.
Okay, yeah, so. Okay, the syntax area actually, yeah, is to provide, yeah, but, yeah.
So do I always do it for one after return?
Not actually that house. Yeah, so I found syntax is everything to get the syntax. It's not always.
So should there there's not a.
Okay, yeah. This. Oh. Unfortunately, I actually ran out of time, so I'm sorry.